Okay, we're going to go over chapter 17, section D, implication and equivalence. So in implications, when we have two propositions linked with if and then. Okay, so the implicative statement if P then Q is written with P, an arrow, and Q, and it reads P implies Q. The P is what has to happen first. That is our antecedent. Q is what happens second. That's the consequent of our antecedent. That's called the consequent. So, for example, we can have the proposition Cato has a TV. This is our antecedent. And our consequent, Cato can watch TV. So we have the implication P implies Q. If Cato has a TV, then Cato can watch TV. So let's look at a truth table for what these implications actually looks like. So we're going to have the antecedent, it will rain on Saturday, and the consequent, the Falcons will win. So our implication, P implies Q, is if it rains on Saturday, then the Falcons will win. So let's look at what the truth table actually looks like. So let's look at the scenarios. So the Falcons do win. Excuse me. It does rain on Saturday. That's our antecedent. And the Falcons do win. That is our consequent. That is exactly what we predicted would happen. So our application is true. The other scenario is it does rain on Saturday, but the Falcons don't win. Our prediction was false. Another scenario is that it doesn't rain on Saturday, and the Falcons do win. In this case, our implication is true because we had only made a prediction. We had only said what was going to happen if it rained on Saturday. We didn't specify what would happen if it didn't rain on Saturday. So because we didn't specify what would happen if it didn't rain on Saturday, our implication is still true. We had only said this is what would happen if it rains. If it didn't rain, our implication remains true. Okay, so if it does not rain on Saturday, the Falcons don't win. This is what happens in this scenario. Again, we didn't make a prediction as to what would happen if it didn't rain on Saturday, so our implication is true. So here is a condensed version of this truth table. P implies Q. And we get this side note. P implies Q is only false if the antecedent is true, but the consequent is false. Let's go look at equivalences. So when we have an implication linked with if and only if, this now becomes an equivalence. P if and only if Q is written with a double-sided arrow, P and Q. So P if and only if Q is logically equivalent to the conjunction of the implications P implies Q and Q implies P. So remember back from section C, a logical equivalence is when we have two statements with the same exact truth table column values. So let's see if we can prove this. So let's look at our antecedent and consequent. Antecedent, I will pass the exam. Consequent, the exam is easy. So we have the implication P implies Q. If I pass the exam, then the exam is easy. We also have an implication Q implies P. If the exam is easy, then I will pass it. We can also have the equivalence, excuse me, not logical equivalence, just equivalence. P if and only if Q, I will pass the exam if and only if the exam is easy. These first two are implications. This one now becomes an equivalence. So let's see the table for equivalences. So we're not going to build a truth table for an equivalence. We're going to construct a truth table of its logical equivalent, the conjunction of the two implications. Because remember, once we have the conjunction of the two implications, we know that the conjunction of the two implications is logically equivalent to the equivalence if and only if. So we have these propositions. P is true here, P is true here, false here, false here. These are the possible combinations. Now remember, in order for the implication to be true, we can have the antecedent and consequent be true, the antecedent be false, consequent be false, that remains a true, antecedent is false, consequent is false, our implication is true, the implication is only false when the antecedent is true and the consequent is false. So we have these two implications. And here's the conjunction. If P, then Q, we know that was true right here in this situation. And if Q, then P, that was true in this situation. Remember, when we have a conjunction, both values have to be true. So our conjunction remains true here. In this situation, the conjunction of the two implications is false because not both implications were true. Same situation here. We have one implication is true, the other implication is false. Our conjunction is false. Bottom scenario, both of the implications are true, so our conjunction is true. So then let's actually have the truth table column values for the equivalence. Remember, it says the logical equivalence is the conjunction of the two implications. So the conjunction and the equivalence will have the same truth table values. So this is true, this is false, this is false, and that's true. So let's condense it a little bit. When P is true and Q is true, the equivalence is true. When P is true and Q is false, the equivalence is false. When the antecedent is false and the consequent is true, equivalence is false. When both the antecedent and the consequent are false, the equivalence is true. The equivalence, P if and only if Q, is true when P and Q have the same truth values. So here we have the same truth values, both are true, the equivalence is true. Here we have the same truth values, both are false, the equivalence is true. So let's look at an example. This is number 3 out of section 17D. It says, write down the equivalence P if and only if Q. I'm not going to write it all out, so I'm just going to say it. So Rome is the capital of Italy, is the antecedent, and Paris is the capital of France. Actually, I suppose I can write it out. So if Rome is the capital of Italy, now remember, we're looking for the equivalence here. If and only if Paris is the capital of France. French. Now, is this equivalence true? Yes, it is. Rome is the capital of Italy. Paris is the capital of France. We have the same truth values. This is true. This is true. Our equivalence is true. Look at the second one. 2x plus 3 equals 10. Now my computer's messed up. I don't know which my equal sign is. Equals 10 is an expression if and only if 2x plus 3 is an expression. Now, is this equivalence true? No, it's not. It is false. 2x plus 3 equals 10 is not an expression. It's an equation. 2x plus 3 is an expression. It is true. So we have a false value here and a true value here. Our equivalence is false. Last one. Cows have 9 legs if and only if horses have 5 heads. Is this implication true? Yes, it is. This value, or the antecedent, is false. Cows don't have 9 legs, they only have 4. And the consequent, horses have 5 heads, is also false, because horses only have 1 head. When both the antecedent and the consequent are false, they have the same truth values, our equivalence is true. Let's try number 1. In the following implicative statements, state the antecedent and the consequent. So, for A, the antecedent is I missed the bus. And the consequent, I will walk to school. So this is what has to happen first, the antecedent, in order for the consequent to happen. So for B, the temperature is low enough is the antecedent. The lake will freeze is the consequent. Antecedent, x is greater than 10, x is greater than 20. Consequent, x is greater than 10. Antecedent, you jump all hurdles, all 8 hurdles. Consequent, you may win the race. So, that is section D, which deals with implications and equivalences. You're ready to discuss. Also, I hope this helps, so you can now go ahead and do the homework that's assigned for tonight.